All right, here we go. This is the video for section 5.4, which is all about the sum and difference formulas for sine and tangent. So in 5.3, we found those formulas for cosine. Now we're going to use those to come up with formulas for both the sum and difference of sine and the sum and difference of tangent. Okay, but before we get into that, go ahead and pause the video and fill out all of the identities that we have done so far on page 1 here of section 5.4. And then once you get it all filled out, unpause the video so we can see how you did. Okay. All right, so all of our reciprocal identities, cotangent and tangent, are reciprocals. Cosine and secant are reciprocals, and sine and cosecant are reciprocals. The Pythagorean identities are, we should have put a cosine squared in, a tangent squared in, and a cotangent squared in, right? Our negative identities, which we will use again today, remember the only ones that change, or I guess I should say the only ones that don't change when we're going from a negative angle to a positive angle is cosine. Right? Cosine of a negative angle is exactly as the cosine value of the positive angle. Okay, so that one stays the same. Anything else, if you're going from a negative angle to a positive angle, you have to negate the trig function value. Okay, very important. And then another relationship we're going to use over and over and over and over again is the relationship of sine and cosine to tangent and cotangent. Okay, tangent is a ratio of sine over cosine. Cotangent is a ratio of cosine over sine. All right, so now that we're refreshed on all our nice little identities, I want to quickly remind you of the two cosine formulas that we came up with, right? Last time we came up with a difference formula for cosine. If we have cosine of A minus B, remember this is like our first angle and this is our second angle. And it was cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle, right? So all we really had to remember is that we do our cosine values first of angles A and B, and then we do our sine values of angles A and B, right? And then the cosine identity for addition was very similar, right? If we had A plus B, we still have cosine A, cosine B, but then we subtract our sine product, right? Sine A, sine B. So a good way to remember these, you know how I like to come up with little random things to help us kind of remember these so we can recall them quickly, is notice on both of these, we're doing the cosine of the first and second angle, right, on the first term. And on the second one, we're doing the sine value of the first and second angle. The only difference is we have to remember the signs, okay? So the way that I remember this one is cab-sab. Cab-sab. Cab-sab, okay? So what this means is we do the cosine of the first and second angle. So cosine A, cosine B is our cab, cosine A, cosine B. And then we do our sab, which is the sine value of our first angle A and our second angle B. Okay, so cab-sab lets you know you're doing cosine of both angles and sine of both angles. And the signs in the middle change, right? If we start out with a subtraction, then it changes to an addition of terms. If we start out with an addition, it turns into a subtraction, which kind of doesn't really make sense, right? But it doesn't really have to make sense. So the way that I remember this is when we're dealing with cosine. Cosine sounds like cos, cause it doesn't have to make sense. Cause it doesn't have to make sense. Okay, so if you can remember cab-sab, because it doesn't have to make sense, you know you're doing the cosine of your first and second angle. Your second term is your sine of your first and second angle. And then the sine in between, it doesn't make sense to change it because it doesn't have to make sense. But it helps you remember to change it, even though it doesn't make sense. because it doesn't have to make sense, right? All right, so that's a little reminder for our cosine identities. Now what we want to do is we want to derive identities for the sign of an addition and also the sign of a difference, okay, or a sign of a subtraction. So what we're going to be doing over the next couple pages is just deriving these identities or proving these identities. And then I'll give you a fun way to remember the sign identities as well. Okay? All right. So we will derive the identities for sine, and we're going to recall an our cosine of a difference. And then this was also a cofunction identity, right? if an angle and its complementary angle add to 90, then we know sine of one of the angles is equal to cosine of the other angle. And this is true for any theta that we can think of. Right? So what I'm going to do is I'm going to pick a specific theta. I'm going to say, let's let theta equal a plus b. So I would put a plus b in for theta here, and I would also put a plus b in for theta there. Okay, so that's what this is saying. If we combine the two, excuse me, and I am choosing specifically to put a plus b in for theta, then what I end up with is sine of a plus b, which we have for us here, is equal to cosine of 90 degrees minus a plus b. Okay, so I want to see if from this I can derive a formula for sine of a plus b. So let's look at this slide. I'm going to go ahead and I'm going to distribute this negative into both terms. So this tells me that cosine of 90 degrees minus a minus b. Okay, and then what I'm going to do is I'm going to group these two terms together and call that my first angle. Okay, because remember, whenever we have cosine of an angle minus another angle, we have a formula for that. So basically what I'm doing is I'm calling my first angle 90 degrees minus a, and I'm calling my second angle b. Okay, so now I'm going to refer back to this difference identity I have for cosine, which says cab-sab, right? Cab-sab. I do cosine of the first and second angle. So this is going to be cosine of 90 degrees minus a, and cosine of b. So that was the cab part of it. Because it doesn't have to make sense since it's a subtraction, right? We know it turns into an addition of terms. So this was the cab part. Cab, now we need to do sab, which is the sine of the first and the second. So we're going to do the sine of 90 degrees minus a and the sine of b. Okay, so just using this identity to plug those in. And now we can actually do a couple more improvements, because if you notice here, cosine of 90 minus a and sine of 90 minus a, these are our cofunction identities, right? Cofunction identities. And with cofunction identities, remember, the cosine of one angle is equal to the sine of its cofunction identity. So the angle that I would have to add to this for it to total 90 degrees would be a, right? So this just turns into sine a cosine b. And over here, same thing, cofunction identity. Sine of 90 minus a is going to equal to the cosine of its complementary angle. So that would be cosine a times sine b. Okay. All I'm doing is using those cofunction identities. And now I have a new formula for sine of a plus b. So here's my new formula. I have the sine of any two angles, a plus b, is equal to sine a cosine b plus cosine a sine b. So now we have a new identity that we need to be familiar with. Okay, and I'll help you in just a second. When we come up with the other sine formula, I'll share with you a fun way we can remember it. Okay, all right. So now that we have the first formula, we can actually use this first formula that we've come up with, which is the addition identity for sine, to come up with the subtraction identity for sine. Okay, so if I start with sine of a minus b, I have an identity for an addition. So I want to be able to write this as an addition. Okay, so what I can do is I can just rewrite this as sine of a plus a negative b, right? Because we can always represent subtraction as an addition of a negative number. So I'm just going to put the plus sign in there because we know that a positive and a negative when multiplied together becomes a negative. I'm just adding in a little extra step there. But now this is written as an addition of two individual angles. So I can use this formula that we just came up for an addition of sine, or an addition of sine angles, right? So now that we have that addition, I can plug it into here. So that says, excuse me, that this is equal to sine of my first angle, so this would be sine A, times cosine of my second angle, so cosine my second angle here is negative b, plus cosine of my first angle, so cosine A, and sine of my second angle, so sine my second angle is negative b. Okay, so just plugging it into this identity we just came up with, this is what we get. And then remember, we want to come up with a formula similar to this one where we have only positive angle values. So I'm going to go ahead and use this one and replace it with our negative angle identities. Okay. So that tells us that this is going to be sine A. Now cosine of a negative angle is the same thing as cosine of the positive angle. So this just becomes cosine B plus cosine A times sine of a negative angle. We can write that as sine B, but it will give us a negative value. So this is the same as negative sine B. Right? So on this second term, when I do a positive times a negative, that's going to make this product negative, right? So I end up with sine A cosine B minus cosine A sine B. So I'm just going to write that negative in front of this product, okay? And that gives us our second sine identity. So this tells us that sine of A minus B is equal to sine A cosine B minus cosine A sine B. And that's our second identity for sine. Okay, so as promised, I want to help you come up with something that helps you remember this. All right, so now we have our two sine identities, but I'm actually going to modify it a little bit. I'm not going to change the identity itself, but I do want to modify it because it helps us remember it a little bit. Kind of like when we looked at our cosine one, we took cosine of both A and B and sine of both A and B, and that helped us write it as cab-sab, right? Because we're doing cosine of AB, sine of AB, makes a nice little pattern, right? So on this one, I want to change the value. Now, if you look at these are exactly the same, right? The only difference between my addition identity and my subtraction identity is the sign in between the terms. But the actual terms are exactly the same. So what I want to do is I want to create kind of a unique pattern. So on this second term, notice it's cosine A sine B. We could actually write this in the reverse order. I could write this as sine B cosine A, and it doesn't change the value, right? When I multiply two things together, if I do 1 times 4, that gives me the same thing as 4 times 1, right? Multiplication is commutative. So I'm actually going to rewrite this identity and just kind of switch the order of those two factors. So let me just rewrite this. Hopefully you use pencil. I meant to do this before I boxed it in, but I forgot. Okay, so I'm going to write the second term as sine B cosine A. Okay, and I can do the same thing on this second term, right? This one I can also write the sine B first and the cosine A second. As long as I keep that term negative, it doesn't matter which order the two factors are in. So I'm going to rewrite that one also. And like I said, you don't have to do this, but it makes for a nice little pattern that helps us remember it. So I'm going to write this as the sine B and then the cosine A. All right, so the little pattern that I was trying to create here is one, it's easier to remember if you go in the same order. So notice in both terms we're doing sine and then cosine. Sine and then cosine, right? Same thing down here. Sine and then cosine, sine and then cosine. But we have to remember which angle goes where because this one's specifically sine of A, this one's sine of B, and then the cosines, they're reversed. We do the second angle first and then the first. So the way that I remember that is I take these big capital A, B, B, A, and I'm going to remember, excuse me, I'm going to remember ABBA. A, B, B, A. Okay, ABBA. So that I remember first angle, second angle, first angle. Okay, now I thought, how is that going to help me remember this? ABBA. What is ABBA? So for those of you who are raised in church, you may have heard that one of the names that people call God is Abba, which means Father. Abba, Father, and referencing God as our Heavenly Father, which when I first heard about that, I thought, oh, that's so cool, right? And then it hit me. That's how I'm going to remember this. Abba is so cool, so cool, so cool, so cool, right? Notice what's interesting about so cool. It's a sine and a cosine. It's a sine and a cosine. ABBA, so cool, so cool. So we're going to do sine of A, cosine of B, so cool, ABBA, right? So cool, BA is the second half of ABBA. So we do sine of the first, cosine of the second, sine of the second, cosine of the first, okay? So if you can remember ABBA, is so cool, then that's a good way to remember it, okay? The other thing is on our cosine identities, remember if it was a negative, if we started with a difference, then we actually added the terms, which kind of really didn't make sense. So we said, because it doesn't have to make sense. And then we can remember easily that if we start off with a negative, we actually turn out with a positive, because it doesn't have to make sense. Cos, right, cosine doesn't have to make sense. So our signs change. But on our sine identities, right, if we start with a positive, we get a positive. If we start with a negative, we get a negative. Because it would be a sin to change that up, right? It would be a sin, sine, it would be a sin to change it. So we're not going to change it. It would be a sin to change signs. Okay, it would be a sin to change signs. So I hope that helps you remember. For cosine, if you can remember cab sab, because it doesn't have to make sense. We know we do cosine of both angles, sine of both angles, and whatever sign we started with, a difference or addition, we change it, right? For sine, if you can remember ABBA, so cool, we know to do sine of the first, cosine of the second, and then sine of the second, cosine of the first, and it would be a sin to change the sign. So if we start with an addition, we get an addition of terms. If we start with a subtraction, we get a subtraction of terms. Again, just something fun that hopefully will help you remember it. If not, that's okay. We're going to move on. So now we have identities for cosine. We have identities for sine. Now we just need identities for tangent. Okay, so our formula, remember, for tangent is we can write it as a ratio of our sine and cosine values, right? So our formula for like tangent of A plus B, I could write this as sine of A plus B over cosine of a plus b. And now we have formulas for this. Now we have formulas to simplify this. Yay! Right? Because we had the cosine of a sum. We did that one in section 5.3. And now in this section, we just came up with our addition for a sine formula. Okay, so on the next page, that's exactly what we're going to do. We're going to take tangent of a plus b. We're going to write it like this, and then we're going to simplify top and bottom using those formulas we just came up with to see if we can find a formula for tangent. Okay, so let's go over to our next page, and I'm going to go ahead and rewrite what we just wrote. We know that tangent a plus b is equal to the sine of a plus b over the cosine of a plus b, right? And now we can go ahead and write out those formulas. So just to help you out, I went ahead and put them at the top of the page here. So sine of a plus b, we can replace with sine a cosine b plus sine b cosine a, because that's our so cool ABBA, right? Started with an addition. It would be a sin to change it away from an addition. And then we use our cosine. Our cosine identity is cab-sab, right? We do the cosine of both. Cosine A, cosine B. We change the sign because it doesn't have to make sense for cosine, right? And then we do the sine of both. So sine A, sine B. All right, so now that we have it all filled in, that's great. But remember, we're trying to come up with a formula for tangent. So we really would like it in terms of tangent. So I'm going to say over here, want in terms of tangent, if possible, right? So I'm going to look at just my first term. I'm not going to look at this whole mess. I'm just going to look at this first term in the numerator. If I wanted a tangent here, right? Remember, tangent is sine over cosine. So looking at this first term, if I would like for that to just end up being tangent of something, right? I already have a sine A, but in order for it to be tangent, I would need this sine A to be over a cosine A, right? And I would need to not have cosine B there. So that's what I'm going to do. I'm going to multiply by something that will make this first term turn into just tangent A. So what I need to multiply by is I need a cosine of A on the bottom, and I also need a cosine of B on the bottom. That way my cosine B will cancel out, and my cosine A on the bottom will make this a tangent A, right? But I can't just multiply this one term by that. I have to multiply the whole top and the whole bottom by that. So I'm going to write it out like this. I'm going to take 1 over cosine A cosine B. And I'm going to multiply it by this top piece. Sine A cosine B plus sine B cosine A. And I'm going to do the same thing on the bottom. Because when I multiply by this, I have to multiply by a number over itself, or in other words, a form of 1, right? If I multiply by anything other than a form of 1, it changes the value. So I have to multiply by the same thing on top and bottom. So I'm just writing it out so you can see what I'm multiplying by. And remember, the reason that I specifically chose to multiply by this is because now when I multiply these first ones together, notice what I end up with is I'm going to have a sine A on top, right? I'm not going to have this cosine B because it's going to cancel with that cosine B, but I will have a cosine A on bottom. And that's going to give me the tangent that I wanted, right? So now let's see what the rest of the terms, what happens with the rest of the terms. If I look at this one, when I multiply this times this, Now I'm going to have a sine B left because sine B doesn't cancel out, right? Sine B. I'm not going to have a cosine A because this cosine A is going to cancel out with this cosine A, right? But I will have a cosine B on bottom. And that works out because now that's a tangent, right? So hopefully this works for all of our terms. Let's look on the bottom. On the bottom, when I multiply, notice this is exactly that thing's reciprocal. So anytime I multiply by a number and it's reciprocal, this is all going to cancel out, right? And I'll just be left with a 1. And when I multiply this times the second term, unfortunately, nothing's going to cancel out, right? I'm going to have sine A, that does not cancel with anything. And I have sine B, and that doesn't cancel with anything. So I'm going to be left with, this is still a negative term, sine A sine B over cosine A cosine B. But that does work out because notice if I just look at these two terms, that's tangent. And if I just look at these two, that's also a tangent, right? So I'm going to go ahead and write this how it looks now. So what we ended up with here is that tangent of A plus B is equal to, this first term on top becomes just tangent A, right? Plus my second term on top, sine over cosine, that's going to give me tangent B. All over, I ended up with a 1 minus, now here, sine A over cosine A is tangent A, and sine B over cosine B is tangent B. So even though they're not separated, I can still write it in terms of tangent. So this is my formula for tangent. Okay. Whew. Right? Okay. So this was the sum identity for tangent. Now we need to come up with a difference identity for tangent. But the good thing is this one's way easier. Like, way easier, okay? Because we can use this one. We can use this identity that we just came up with, and we want to rewrite it as a difference. So remember, the way that we can rewrite this as a difference is I can say tangent of A minus B is the same thing of tangent A minus, right? Or not minus, plus, because we want to change it to a plus a negative B, right? Because we want to be able to write this as an addition so that we can plug it into this formula we just came up with, okay? So now this is my first angle, this is my second angle, and we're going to plug it into this formula we just came up with. Our formula says to do tangent of our first angle. So we're going to get tangent A plus tangent of our second angle. So our second angle is a negative B all over 1 minus tangent of our first angle, which is A, tangent A, and tangent of our second angle, which is tangent of a negative B. Okay. Now, again, we have negative identities, right? These two right here, these are our negative identities. So we need to know if tangent of a negative B is the same as tangent B, or if the sign changes. And if you look back to your identity page for your negative identities, notice when you have tangent of a negative angle, it does in fact change the sign when we take tangent of the positive angle, right? So I'm going to go ahead and change the sign of this term and this one. So when I change the sign, how is that going to change my formula? This tangent A stays the same, but this is going to become a negative tangent B, right? Negative tangent B. And on bottom, I'm still going to have my 1, right? But if this becomes a negative factor, then this negative times this negative that's already here is going to change this into a positive product of tangent A, tangent B, right? Because this is the same as negative tangent B, and this is the same as negative tangent B. So it's like I'm just substituting those in and changing the signs accordingly, which gives me my tangent formula. So that tells me that tangent of A minus B is equal to tangent A minus tangent B all over 1 plus tangent A tangent B. And I was going to come up with like a clever way for y'all to remember this one, but honestly, it's really not that bad. I mean, even though it has a rational expression, if you look at it, you're doing tangent of A and B, and notice exactly what you're doing. This is an addition. You're doing tangent of A plus tangent B. And then on bottom, you do 1 minus that exact thing. So tangent A, tangent B looks kind of like what you would think it would be from this. And then 1 minus tangent A, tangent B. And the only difference when we do a difference is we start by doing a difference on top. And then on bottom, we do a 1 plus tangent A, tangent B. So I didn't come up with a neat little jingle for that one. I'm sorry. But hopefully it's easy enough that it'll be not sufficiently hard to remember. Okay. Okay. So now that we have all of our formulas, that was the hardest part of this section, was just deriving and getting the formulas. Now that we have them, let's look at what we can do with them. Okay. So here we have that same unit circle, to reference for values. So what we're going to do now is determine which identity would be the best to use in solving these different, in solving these different problems. So the first one is a sine. Sine of negative 15. So there's lots of ways to get a negative 15, right? I could do negative 60 plus 45. I could do 30 minus 45. I could do negative 45 plus 30, right? There's lots of ways to get it. So there are many different ways that you might work this one out. But we do know that we're going to use the sine. And I'm going to go ahead and write it as a subtraction. It doesn't really matter if you want to do it as a subtraction or an addition. But I'm going to go ahead and write this as sine of some value minus another value. Okay? So what would I have to subtract to end up with a negative? Well, I'd have to start out with a positive and subtract a larger number, right? So I'm going to use 30 degrees and 45 degrees. So 30 degrees is my positive, and if I subtract 45 degrees, then that will in fact get me to a negative 15. Okay? All right, so this means I need the sum or the difference, the difference identity for sine. So I'm going to go ahead and just write it up here, just so that I have it. Identity. So we want the sine of A minus B, because we chose to do the subtraction one. So remember, our sine identity is ABBA, which is so cool, so cool. so we're starting out with sine of ABBA is A. So cool. So we do cosine of ABBA, AB, BA, so B. Okay, and remember, it would be a sin to change the sign. So if it is a negative, that means we have a subtraction of terms. So we already did AB. Now we just need BA, right? And it's so cool, so cool. So now we're going to do sine B and cosine A. Okay, so hopefully that helps you remember. So here's our formula, and we have our first value and our second. So let's plug them in now. So when we plug this in, this says we want to do the sine of our first angle. So we're going to do sine of 30 degrees times cosine of our second. So cosine of 45 degrees. And then we're going to subtract sine of our second angle. So sine of 45 degrees times cosine of our first angle. So cosine of 30 degrees. Okay. So now that we have it all filled in, now all we have to do is put in our actual values. So I need to know what's sine of 30 degrees, what's cosine of 45, what's sine of 45, and what's cosine of 30. And we can get that from just pulling it off of the unit circle, okay? So I'm going to go ahead. Sine of 30. Sine is our second coordinate, so that gives me 1/2. Cosine of 45, I go to 45. Cosine is my first coordinate, so square root of 2 over 2. Sine 45 is my second coordinate of my 45-degree angle, which is square root of 2 over 2. And cosine of 30 degrees is my first coordinate on my 30-degree reference point, which is square root of 3 over 2. Then I multiply those together, which gives me square root of 2 over 4 minus square root of 6 over 4. And then remember, we do want to go ahead and write it as one fraction. So square root of 2 minus square root of 6 all over 4. So this is my final answer. Okay, maybe not too bad. Same thing we did with cosine, just now with sine and trig and tangent. All right, so let's look at this next one. Here we just want to figure out what tangent of 13 pi over 12 is. Well, first of all, it's hard to work with radians, so I'm going to go ahead and change our radian measure into degrees. Okay, and the way that we change it from radians to degrees is we take our radian measure angle and we multiply it by 180 degrees over pi. That way our pi's will cancel, and when we multiply 13 times 180 and divide it by 12, that gives us 195. So what we're really looking at is finding the tangent of 195 degrees. Okay, so we're going to have to use one of our tangent identities. Doesn't matter which one. I prefer to do the addition because I feel like it's easier to find two things that add up to something than two things that subtract to something. So I want to be able to write this as the tangent of some number plus some number, right? So I need two numbers that I have nice, good reference triangles for that I can get to add up to 195, okay? So 195 could be what? Maybe that's 180. How about 150? Yeah, 150 and 45. Okay. Now again, you may have been able to come up with a different pairing of numbers that add up to 195, or you may have found something bigger that you could have subtracted to get 195. So again, there's many ways to do these. I chose to do an addition. So I need the addition formula for tangent. So I'm going to go ahead and write the identity that I'm going to use is tangent of A plus B, because I found two numbers that add to 195, right? And my tangent formula says that I do tangent A plus tangent B all over 1 minus tangent A tangent B. So now that I have my formula, I'm going to go ahead and just plug the numbers that I have in so that I can figure out what their values are on the unit circle. So this tells me I'm going to do tangent A. So that means tangent of 150 degrees plus tangent of my second one, so tangent of 45 degrees, all over 1 minus tangent of my first angle, which is 150, times tangent of my second angle, which is 145. Now, this is the easy part, just plugging in the numbers. The harder part on these is to make sure we plug in the correct values. And remember, we want to write it all the way simplified down to one fraction that hopefully doesn't have radicals in the denominator, because my math lab doesn't like that. So let's go ahead and fill in all of our values. So tangent of 150. So let's find 150 degrees here. And the tangent value, remember, is a ratio of sine over cosine. So honestly, since we're dealing with tangent, instead of using the unit circle and having to simplify all of these, I'm going to go back to page 4 of 5.3, which is where I gave you either the chart or the unit circle. and I'm going to use this chart. So I'm looking for tangent of 150 degrees. So I'm going to go down to degrees and find 150 and go over until I have my tangent value, which you can see here is negative square root of 3 over 3. So I'm going to go ahead and do negative square root of 3 over 3 plus the tangent of 45. So again, on my chart here, I'm going down to 45 degrees, and I'm going across until I find the tangent value, which is 1. So this just becomes 1. And then on bottom, I have the 1 that's already there, and then I'm subtracting, and I can just now reference these numbers, right? Because these are the same values that I have to find on bottom. Tangent of 150 is going to be negative square root of 3 over 3 times the tangent of 45, which again is 1. So now I just need to do some simplifying, right? So on top, I need to be able to combine these into one fraction. So in order to do that, I would need a common denominator. So I could write this as 1 over 1, or in this case, because I need a 3 on the bottom, I could write it as 3 over 3. So I'm going to write this as negative square root of 3 over 3 plus 3 over 3. So just getting a common denominator here. Okay. On bottom, I'm going to have 1, and then notice these double negatives are going to make that a plus, right? And I have square root of 3 over 3. Now again, I'm going to need a common denominator. So just like I did on the top, instead of writing this as a 1 or a 1 over 1, because I want to end up with a denominator of 3, I'm going to go ahead and just write this as 3 over 3. Okay. All right. And now I can go ahead and simplify a little bit. So I end up with negative square root of 3 plus 3 all over 3 on top. And on bottom, I have 3 plus the square root of 3 over 3 on bottom. Okay. So remember, double or a complex fraction, a fraction within a fraction. Remember, this is just a division, meaning we can flip and multiply by the bottom, right? So this is the same thing as saying, I'm running out of room here, negative square root of 3 plus 3 over 3, and we're going to flip and multiply by the reciprocal of the bottom. So 3 plus square root of 3, right? And then my 3's cancel, so that's good. So I have negative square root of 3 plus 3 all over 3 plus square root of 3. Now, in a perfect world, we would be able to stop here. But unfortunately, we're using software for this class, and my math lab will not accept an answer that has a denominator with a radical in it. So we need to rationalize the denominator. And I know we've gotten really good at rationalizing the denominator when it's just a single term radical, right? So I'm going to do a blast from the past here, from good old college algebra. When we have two terms, we have to multiply by the conjugate. And multiplying by the conjugate means this exact same expression, but I changed the middle sign. So that's 3 minus square root of 3, 3 minus square root of 3. Okay? And the reason we're doing that is just to get rid of the radical in the denominator. So now I just need to distribute this out so that I have an answer that doesn't have a radical in the denominator. So I apologize, this one's got a little bit extra work to it. So if I start distributing negative square root of 3 times 3, right, that's going to give me negative 3 square root of 3. Negative root 3 times negative root 3. Well, a negative times a negative gives me a positive. And square root of 3 times square root of 3 is square root of 9, which is then just 3. Then I want to distribute this 3. So 3 times 3 is 9. And 3 times negative square root of 3 is negative 3 square root of 3. All over. Now on bottom, you can write it all out and then simplify it. But the reason we're multiplying by this is just think about it. When we do 3 times 3, that's going to give us 9, right? When I do 3 times negative root 3, that's going to give me a negative 3 root 3. And then when I do this root 3 times 3, that's going to give me a positive 3 root 3. So negative 3 root 3 and positive 3 root 3 will cancel. So those two middle terms are going to cancel out. And then when I just distribute my last term times my last term, square root of 3 times negative square root of 3 is going to give me negative square root of 9, which is just negative 3. Okay? So if you need to multiply all that out and sit and ponder on that for a minute, that's totally fine. But I'm going to go ahead and keep simplifying. So I combine like terms. So negative square root of 3 and negative, or, oh my gosh, I can't say what I'm pointing at. Negative 3 root 3 and negative 3 root 3 gives me negative 6 root 3. And then 9 and 3 gives me 12. And that's all over 6. Okay, so I have something that doesn't have a radical in the denominator, thank goodness. And then I just want to make sure it's completely simplified. Since both terms are divisible by 6, I'm going to go ahead and reduce this. So if I reduce this one by 6, I get negative square root of 3. If I reduce 12 by 6, I get a positive 2. So this is the tangent value for 13 pi over 12, or 195 degrees. Okay. Okay, so let's just quickly refresh. First thing we did was change it to degree form so that it was easy to work with. Then we found two numbers that either add or subtract to give us that degree value. Once we know our two angle measures, then we plug it into our tangent formula. And then all the rest of this was just simplifying to get it down to one formula that did not have a radical in the denominator. Okay? All right, so I am going to do one more, and then I want y'all to try one that hopefully won't offend you greatly. Okay, so number 1 and number 2 was starting from the left side of the formula, and we simplified the right side of the formula. But remember, just like with cosine, sometimes it's better to start with the left side of the formula and write it as the right side so that we can simplify. Because if you look at number 3, we can't look up tangent of 100 or tangent of 70. That doesn't work. So we want to see which tangent formula did I start with here. Okay, so notice this tangent was an addition, and we had an addition on top, right? And notice here we have a subtraction. So this would have had to have been that we started with the tangent of a subtraction, something minus something, right? Because if we would have started with an addition, we would have had an addition on top. We have a subtraction on top. So that means that my first angle is 100, my second angle is 70. So 100 degrees minus 70 degrees gives me a tangent of 30 degrees. And now that's something that we can look up on our unit circle or on our chart, right? Anytime we have to look up tangent, I pretty much use the chart just because we don't have to calculate off the unit circle. So I go down to 30 degrees, which is right here, and I trace it over to find our tangent value, which is square root of 3 over 3. So my answer would just be square root of 3 over 3. And that one was a lot easier than the last one, right? Okay, so for page 5, what I want you to do is to write each expression and simplify it as much as you can using the identity that it's showing demonstrated. Okay, so we're going to write it out using the formula that corresponds to it so that we get a simplified expression that just has theta in there, right? Because 270 is something that we can look up on our unit circle. 3 pi is also something we can look up on our unit circle, right? Okay, so I want you, go ahead and pause the video, figure out the sine formula to use here, plug your first and second degree values into that formula, and then simplify it as much as you can. Okay, I'm going to give you just a second. If you get stuck or you finish and you're ready to be checked, unpause the video and we'll go over it. Okay, let's see how you did. First thing we need to know is what formula to use. So this is a difference formula for sine. So I went ahead and wrote that formula here. So when you write it out using theta as your first angle and 270 as your second, you should have gotten sine theta cosine 270 minus sine 270 cosine theta. And when you figure out that the cosine of 270 is 0 and the sine of 270 is -1, the first term goes away and the second term just becomes cosine theta, right? Hopefully we're okay with that one. Moving on to number 2, we're using the addition identity for tangent. And it's easier to do in degrees. So I'm going to change this 3 pi to degrees. So 3 times pi is the same as 180 degrees. So 3 times 180 is 540 degrees. And that's not something I can look up on my chart or my circle because that's more than one rotation, right? So I just want to figure out what's its similar angle, right? As long as I find an angle that has the same terminal side, I can use it. So I'm just going to subtract off a full rotation of 360 degrees, which gives me 180. So 540 degrees is the same as 180 degrees. So I just replaced my 3 pi with 180. And now I can plug theta in as my first angle and 180 in as my second angle. So once I plug those values in, I end up with a 0 for the tangent of 180 on top and bottom here, right? So the top just becomes tangent theta, and on bottom, this second term just becomes 0, so I'm left with just a 1. And tangent theta over 1 is just tangent theta, right? All right, so I want to show you 2 more problem types that you'll see in this section or on the worksheet, and then we'll be done, 5.4, okay? All right, so the first problem type is using reference triangles. We did one like this at the end of section 5.3, where they're going to tell you something about the given angles, and we'll use reference triangles to figure out as much as we can about them. So notice here it says, suppose that A and B are angles in standard position with cosine A equaling -7/25 for this angle A that happens to be between pi and 3 pi over 2. So I'm going to stop right there and just think about this. If I were to draw this angle in standard position, what this is saying is that my angle A is somewhere between pi and 3 pi over 2. So pi is right here, right? And 3 pi over 2 is my next quadrantal angle. So what they're telling me is that my angle A is somewhere in here, right? This is angle A, okay? So what I want to do is I want to go ahead and create a reference triangle so that I can figure out everything I need to know about angle A. So what they're telling me about angle A is that its cosine value, which is our adjacent over hypotenuse, is -7/25. So we know this adjacent side is -7. We know our hypotenuse is 25. The only side we don't know is this opposite side, or our y value, right? So I'm going to go ahead and just solve using the Pythagorean theorem to figure out what this unknown y value is. So I take my x value squared, so -7 squared, plus my y value, which I don't know, squared, and that should equal 25 squared, right? Just using the Pythagorean theorem. So that tells me that 49 plus y squared equals 625. And then I'm going to go ahead and subtract that 49 to the other side. So I get y squared is equal to 576. And then I need to take the square root. Now when I take the square root, I'm going to get plus or minus 24. So looking at my y value, because it's over here in quadrant 3 and it's below the x-axis, we're going to use the -1. Okay? So y equals -24. Okay, so now I have everything I need to know about my angle A. Okay, so there's that. There's that piece. So Cosine A, negative 7 over 25, where A is between pi and 3 pi over 2. Now it says, and sine of B. B is a different angle. This is all about A. So sine B is negative 3 over 5, where B is between 3 pi over 2 and 2 pi. So I'm going to make a new little picture for sine B. So it says B is between 3 pi over 2 and 2 pi. So my angle B is somewhere over here, right, in standard position. Okay, and what they're giving us is the sine value. So the sine value is the opposite over hypotenuse. So I'm going to go ahead and draw my reference triangle. We know the hypotenuse is always positive, so we can go ahead and put a positive 5 there, and my opposite side is negative 3. So the only side that I'm missing is that x value, or that adjacent side, right? So I'm going to go ahead and solve it using the Pythagorean theorem again. So we know that x squared plus my y squared, so negative 3 squared, equals my hypotenuse squared. So that means that x squared plus 9 equals 25. And then I subtract my 9 to the other side. So that means that x squared equals 16. Then I take the square root of both sides. So that means that x is equal to plus or minus 4. Now, because our angle is down here in quadrant 4, we can see that our x value here should be positive. So that means we should get a positive 4. Okay. So now I have everything I need to know about angle A. I have everything I need to know about angle B. Now let's see what they want us to find. Find the following. Number 1 says find sine of A minus B. So I'm going to go ahead and plug in my formula, right? Sine is ABBA, so cool, right? So that means we do sine A cosine B would be a sin to change the sign, right? So minus sine B cosine A. Okay, so now all we have to do is figure out what those values are here. Okay, now for A and B, we just need sine and cosine. So cosine of A was already given, and sine A we can find because now we know the opposite value. So opposite over hypotenuse would be negative 24 over 25. And then the same thing with B. The B sign was given, so we just need to know the cosine of B. Cosine is adjacent over hypotenuse, so 4/5. So now we should have all the values we need to plug in here. So sine of A is negative 24 over 25, right? We got that from doing our reference triangle. Cosine B, we got from doing our reference triangle for B, which is 4/5. Minus sine B, which was given, right? Negative 3/5. Times cosine A, which was given, negative 7 over 25, right? And now we just simplify. So we multiply straight across. That gives us negative 96 over 125. And here when I multiply a negative times a negative times a negative, I end up with a negative 21 over 125. And when I combine those, it gives me a negative 117 over 125. Excuse me. And that's as simplified as it gets. Okay? Now let's look at number 2. Number 2 is finding the tangent value. So we're going to do tangent of A minus B. My tangent formula for a difference is to do tangent A minus tangent B, and then 1 plus tangent A tangent B. Now, we don't have tangent values, right? Dang it. We only have sine and cosine, but we should be able to find tangent values because we have the reference triangle, right? And remember, tangent is opposite over adjacent. So let's go ahead and simplify here. Tangent A, so go to our A, we need TOA, opposite over adjacent. Opposite is negative 24 over the adjacent, which is negative 7. Negative over negative becomes positive. So we have 24 sevenths minus tangent B. So I need to know the tangent of this one. Opposite over adjacent, so negative 3 over 4. And then on bottom, I'm going to do 1 plus tangent A, which we found to be 24 sevenths, times tangent B, which we found to be negative 3/4. Okay. So I want to simplify this as much as I can. This is going to turn into an addition, but I definitely need a common denominator here, right? Or you can use your fraction button on your calculator. So let's go ahead and change this into 24 over 7 plus 3/4. And then on bottom, I'm going to have 1. When I multiply these, I'm going to get a negative number. And I'm going to go ahead and reduce. I know that 4 goes into 24 6 times. So that gives me 18 over 7. Now, for the sake of time and getting lots of common denominators, I'm going to go ahead and just do this using my fraction button. So on top, I have 24 over 7 plus 3 over 4, which gives me a mixed number. Now, using that fraction button to change it from 4 and 5/28 to an improper fraction, you just use the second function of your fraction button. Okay, so on top, I end up with 117 over 28 divided by the bottom, which is 1 minus 18 over 7. Again, I'm going to have to change it to an improper, so I use the second function of my fraction key, which is negative 11 sevenths. Excuse me. And then we know we can flip and multiply by the reciprocal. So 117 over 28 times negative 7 over 11. And then here you can go ahead and just continue to multiply using the fraction button on your calculator, or I'm going to go ahead and just reduce, because I know if I reduce this to 1, I can reduce this to 4. So I end up with negative 117 over 44 as my tangent value. Okay, so that was number 1. Number 2, and then number 3 is the quadrant of A minus B. Now, A minus B is a new degree measure, right? So I can't use these reference triangles that I used. So I have to think about, okay, where would the quadrant of this angle be? Well, all I know is the sine value of the angle and the tangent value of the angle. Okay, I know they're both negative. So let's think about where tangent values are negative, right? Tangent value is a ratio of sine and cosine. So here, sine is positive, cosine is positive, which means that tangent's positive. So that's not 1. Here, I know that sine is positive and cosine is negative. So this gives me a negative tangent, right? Down here, in both of these quadrants, I know my sine value is negative, right? This gives me a negative sine, and this gives me a negative sine. But which one gives me a negative tangent, right? This one is a negative sine and a negative cosine, which would be a positive tangent. And then over here, I have a positive cosine, a negative sine, which gives me a negative tangent. So since I have already confirmed that my sine is negative and my tangent is negative, the only possible quadrant where both sine and tangent are negative would be quadrant 4. So that would be my answer for part 3. Quadrant 4. And my reasoning is right there. Okay. All right, I want to show you one with a proof where you have to verify that something is true, and then that will be the end of 5.4. All right? Okay, so let's look at this one. If I want to verify that this side equals this side, I'm going to start with the left-hand side because this just says that I want to calculate the tangent of an addition and the tangent of a subtraction. So these are two things that I can plug right into my tangent formulas. Okay? So I'm going to start with the left-hand side, and I'm going to do tangent of pi over 4 plus t plus tangent of pi over 4 minus t. So I'm going to plug this one into my tangent formula for an addition. The addition identity for tangent says that I do tangent of my first angle, which is pi over 4, and then add tangent of my second angle, which is t, and I divide that by 1 minus the tangent of my first angle and the tangent of my second angle. Okay, so just plugging these two angles into the sum identity for tangent. Plus, I want to do the same thing with this one. Okay, but this one's a difference. So this time I'm going to do tangent of the first angle minus tangent of the second angle. And on bottom, I'm going to get a 1 plus tangent of the first angle, tangent of the second angle. Okay. Okay. So now that I've done that, I want to see if I can simplify. I don't know what t is, so I can't do tangent of t, but I should be able to look up pi over 4. Pi over 4 is a 45-degree angle, right? So I'm going to find my paper here that has my value. So I look up in degrees a 45-degree angle, or it even has the radian measure here. So pi over 4, if I go over to find the tangent value, it's actually 1. So anywhere I have tangent pi over 4, right, any of these, that's all just going to equal 1. Okay, tangent of pi over 4 equals 1. So I'm going to go ahead and rewrite this now that I know that that's 1. So now what I have is 1 plus tangent t over 1 minus tangent t plus 1 minus tangent t over 1 plus tangent t. Okay, and we're trying to get to this point. So we're not there yet. But if I look at what I'm trying to end up with, I see a tangent squared, right? I see a 1 and I see a tangent squared. This kind of looks like something that would factor into a difference of squares, right? And what I have in the bottom here are two pieces that look very similar to what I would get if I were to factor something into a difference of squares. So what I want to do is I want to build this back up into that type of denominator. Okay, so if I want to end up with a difference of squares denominator, 1 minus tangent t times 1 plus tangent t, 1 minus tangent t, 1 plus tangent t, then I need to multiply on top and bottom by what each one's denominator is missing. This one is missing the 1 plus tangent t. So I have the 1 plus tangent t that was already there, but then I would have to multiply by 1 plus tangent t on top and bottom, right? In order to get this denominator that I need when I'm only given that denominator. Same thing with this one. This one already has a 1 minus tangent t, but what its denominator is missing is the 1 minus tangent t, right? It has the 1 plus, but I need the 1 minus. So I'm going to multiply by 1 minus tangent t on top and bottom for that one. Okay. So now that they have the same denominators, I can go ahead and simplify the tops. So to simplify the tops, we're going to have to FOIL all this out. Okay. So hang with me. Here we go. 1 times 1 is 1. 1 times tangent t is tangent t. Tangent t times 1 is tangent t. Tangent t times tangent t is tangent squared t. And then I'm going to go ahead and add what I get from the second numerator. So 1 times 1 is 1. 1 times negative tangent t is negative tangent t. Negative tangent t times 1 is negative tangent t. Negative tangent t times negative tangent t is positive tangent squared t. Okay, so this is all over that common denominator of 1 minus tangent t, 1 plus tangent t. Okay. So lots of stuff I can do now. So notice what happens is I have a tangent t and a negative tangent t. I have another tangent t and another negative tangent t. So what I'm left with is 2 plus 2 tangent squared t, right? Because I have a 1 and a 1, and then I have a tangent squared t and a tangent squared t all over. Now this, I know if I multiply out, I'll get that difference of squares polynomial, which is 1 minus, excuse me, tangent squared t. So I'm almost to what I need it to be, right? The only difference is I need to end up with a 2 secant squared t instead of this. So I have a 2 in both terms, so I'm going to go ahead and just factor that 2 out. That leaves me with 1 plus tangent squared t all over 1 minus tangent squared t. And then this right here is one of our identities, right? This is our 1/10 second identity. 1 plus tangent squared theta is equal to secant squared theta. So this gives me 2 secant squared tangent over 1 minus tangent squared t, which gives us the right side that we needed. Okay? All right, so that is the end of section 5.4. There is both a My Math Lab assignment and a worksheet for this one. Okay, the worksheet is doing some verifying like this one, and where I just want to see a little bit of your computation skills. Okay, so if you have any questions, please let me know. Otherwise, I'll see you on the next video.